Hi there, this is exercise 7A. We've got a lot to get through. We're looking at a new way of measuring angles, and they're called radians. So let's have a go at this. A little reminder from GCSE Maths. At GCSE Maths, this says find the arc length, which is this distance here. And you should remember this is basically like part of a circle. It's my dodgiest circle ever. But as a fraction of the circle, it's 70/360. So if I want to work out this distance here, I really work out the distance all the way around, and that's called the circumference. And the circumference formula, you may remember, is either pi times the diameter, or actually more usefully 2 pi r. So this is a fraction of that distance. So I reckon this, you should recall, you do it like this. What was my r? My r is 12. So we work out the fraction times by this, and I just typed this in actually. It's 14.66 when you type it in centimetres. So there's my answer. Now, if we use that basic idea, we're going to define a radian to be such that the arc length is r. So what we were just doing, we said the angle, in our case was 70, but in this case it says the angle is theta, over the total angle, 360, times by the distance that you'd get if you did the whole circle, again my dodgy circle there, 2 times pi times r. That has to equal 1 radian. So what I want to know is what angle it will be in order for this to happen. And straight away you notice 2/360 is over 180. So theta over 180. Oh, and the r's cancel as well actually. So I reckon pi equals there and 1. So if I just move that over, theta is 180 divided by pi, and that equals 57.3. And that's what they wanted me to do. They wanted me to show that 1 radian, this angle that you get when you have a sector with the same radius as you have arc length, that angle is 57.3 degrees. And there it is. Take from this, please, 2 things about the 57.3. That's useful, but that's not exact. What's exact really is that pi radians is 180 degrees. This is going to be very useful. So we often have to convert between the two things. So sometimes you're in degrees, sometimes you're in radians. So these are 2 formulas. First of all, if you know how many degrees you've got and they say how many radians, you do degrees divided by 180 times by pi. But notice the formula gets turned around. If I know how many radians I've got, you don't divide by 180, you times by 180. You don't times by pi, you divide by pi. Same formula, just rearranged. So let's use those, and very often if you get asked to find radians, we write the answer in pi, not necessarily as a decimal. I'll show you what I mean by that in a bit. So the first question says convert 1/10 of pi radians. So if I've got radians, I'm going to use this formula. So the degrees will be 1/10 of pi. It says divide it by pi times by 180. Now the whole thing about this is those cancel. So really this is just saying find the 10th of 180, which is 18 degrees. It says convert 3/4 of pi. So again, using this formula, because I've got radians, the number of degrees will be 3/4 of pi. What's it telling me to do? It says divide by the pi times by the 180. And the pi's of course cancel. Really it's just 3/4 of 180. And if you do that, I think you get 135 degrees. This one's a bit less obvious. It's 1.55 radians. So 1.55 divide by the pi and times by the 180. I think it's 88 from memory, because I did this just a while recently. Divide by the pi times by the 180. 88.8 degrees. 72 degrees. Alright, 72 degrees. Well, then I'm using this formula. So on this one I do 72 divided by the 180 times by the pi. Now it says as a fraction of pi. Now I know that's 2/5. 36 goes into both. So the answer is 2/5 of pi. The last one says convert 100 degrees. So again I've got degrees. For this one I'm going to do 100 divided, it says, by the 180 times by the pi. But it wants the answer as a decimal. So 100 divided by 180 is actually 5/9. Times by pi as a decimal I get 1.745. So there's my answers. Right, that's been rounded slightly differently, but that's the same thing. So now here's some questions for you to do. I've shown you the formula. I want you to do them. So pause this and see if you can get them right, and then check your answers. Here's the answers, and here's the answers. So hopefully you're good at those. I want to just remind you very briefly that sometimes you get questions at, and we've seen it already earlier in year 12, we'd say, what is cos of 30? And you can see cos of 30, it says it's root 3 over 2. Now you might be asked to find, for instance, sine of pi by 4. And what I want you to do is you say to yourself, well, pi by 4, well, pi by 4, I need to be able to convert. Now here it tells me what the conversion is, but if you know it's 45 degrees, life is easy. So you say to yourself, I know that's sine of 45, and sine of 45, very, we've got there, it's root 2 over 2. So to a certain extent, some of this can be done on the calculator, but also it's useful if you know them. So you might want to copy down that table into your book, please. Just a little guide on this. We did in the past be able to do this, so you might need to learn how to type these in. Your calculator is probably now on degrees, so we'll do the two easy ones. Sine of 120, as I say, make sure you are in degrees. I just realised I'm not, so I am now, and it says root 3 over 2, so you either remember this or you type them into your calculator. And cos of 240 you can type in the same way. I get minus a half. So now, what I want you to do is to know, if you press shift then set up on your calculator, it comes up with what it calls angle unit. So I'm pressing 2, and then I want to choose to do 2 again for radians. And now on the top of my screen it says R. So here it now says R, telling me I'm in radians. So now I can type in tan of 3 pi, and pi, if you haven't spotted it, is there, shift pi. So I'm typing that in, and I've got 0. So is that right? Here it is. Tan of 3 pi is 0. And this one, cos of 5 pi by 6. So cos of 5 pi by 6. So type that in. I'm typing it as a fraction. Close bracket. And I get minus root 3 over 2. So relatively easy to do, but just get your calculator in the right mode. That's all I'm saying. So just you might want to go back into degrees. Shift, set up, angle unit 1 for degrees. And now you need to be able to move between the two. Hopefully they all agreed. Now you should also remember from work we've done in the past, the cast diagram. This tells us where these things are positive and where these things are negative. So for instance, you'll see that in the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant, every 90 degrees is a quadrant. Sine is positive. I'm writing sine there. In the second quadrant, sine is positive. In the third quadrant, it goes under the graph, so it's negative. This is the third quadrant. So it's not there. And the fourth quadrant, I'm not going to put anything there. So S means sine is positive in those quadrants. And let's look at the cos graph. Cos is positive there, isn't it, in the first quadrant, but then it's negative, and it's not until the fourth quadrant it's positive again. Tan, well, this is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. You can see tan is positive in the first quadrant and in the third quadrant, but nowhere else. And we notice all of them have been positive here, so that's why I cross all those out and I write A. And this is the cast diagram. It tells us where sine, cos and tan are positive. Now use that in a bit. Notice what I'm going to do. It says show theta is 3 pi by 4. If I was doing this, I'd say, what is 3 pi by 4? I'd convert this. Well, I know pi is 180. So this is 3 times 180 divided by 4 is 135 degrees. That's kind of what we were doing before. So when you mark these, you always start on this positive x axis, and 135 is there. So that's my angle. That's what I want you to do on this. And on this one it says minus pi by 3. So straight away, because it's minus, I'm going to go that way round. still going to start on this line. What's pi by 3? Well, pi by 3 is like, if I times that by 180, 3's into 180 goes 60. So this is really, notice what I've done there. What I'm really doing is I'm saying a third of 180 is 60 degrees. So 60 degrees is about there somewhere. That's my angle. This was my angle. That question was just about finding the angles. So I've just put these two cast diagrams up to help us. Now, what I'm after here then, it tells me that sine of theta is 0.6. So I know in here somewhere, sine of theta, and I don't know what theta is, but all I'm going to do is I'm going to draw an angle. And I am told that if I find the sine of that angle, the answer is 0.6. Now, pi, remember, is 180 degrees. So 180 minus theta, if you think about it, I think it's the equivalent over here. I think that's theta there. If you think of all of this as 180 minus theta, all of that, then that's what we're after. And the whole point about this is, if I know that that sine is 0.6, I know that this is also 0.6 over here, because effectively we always find with a cast diagram the angle to this angle here. So what I'm going to get you to do is just use a cast diagram. We know that in the cast diagram the sine will be positive here. So because of this angle here is theta and this angle here was theta, then I think this is also 0.6, because the cast diagram says it's positive in that quadrant. Pi plus theta. If you just think about that, that's pi is 180. So what we're doing now is we're going past the 180 and another theta. So that's theta there now. And can you see this has pulled me into Q3, the third quadrant. It's pulled me into the negative quadrant. So I think this is minus 0.6. This is just, now you can check these on your calculator. You could do the inverse sine of 0.6, get the answer, and then try 180 or pi minus it, depending on which mode you're in. It's a bit tricky this without me being with you, but let's see if we can do this one. So because of it says 4 pi by 9 equals 0.174. So here it's saying it slightly differently. This is my angle, 4 pi by 9. Well, I know pi is 180. So a ninth of that is 20. I think this is 80 degrees. So 80 degrees is roughly there, and it tells me the cos of that is 0.174. And it says, hang on a bit, what is 13 pi by 9? And what you'll notice by that is effectively I've added on, it was 4 pi, it's now 13 pi. I've added on 9 pi by 9. Plus my 4 pi by 9. And of course 9 pi by 9 is a whole pi. So if I add on, if that's my theta, and I add on another, I think it brings me down to here. I think that is what I've got. I don't know exactly how, where it is, but it's definitely in the third quadrant. And the third quadrant will be negative, so it'll be minus 0.174. I think that these two answers are related. What's this one? This is 5 pi by 9. Oh, I see what they've done here. Here they've done 9 pi by 9 minus 4 pi by 9 to give me the 5 pi by 9. And that is effectively the cos then of pi minus 4/9 of pi. Now what would that look like? That's theta. I think it's in this quadrant. So there's my theta. And the great thing about cos is it's negative up there as well. I think this is also minus 0.174. So I do think that's quite confusing without having the benefit of me actually showing you what's going on. Notice one thing, please. You can chuck this into your calculator if you're not sure how to do it. Perhaps I'll show you when I see you in lessons next. And what you're meant to be doing here is exercise 7A. So have a look at exercise 7A, see what you can do. And I mean, as you can see, it says questions 1 to 4. I don't know what was wrong question 5, but then do question 6. Well, best luck.